So on the subject of radicals, here, not an equation, not still the subject. We've switched over to just simplifying, and we've got a square root here, and we are just looking for pairs. Just keep in mind we do have a -2 out in front. Over here we have a +6, and just keep taking out pairs. And just know the -2 is going to multiply to whatever's coming out. So inside 200 is actually a perfect square 100 times 2. All right, so when I take out a perfect square of 100, that would be 10. And so now I'm taking out a 10, okay? And I'm left with a 2. So I'm just going to kind of write it like that. 10 on the outside, 2 on the inside. I'm taking out an M, okay, a pair of M's. Taking out a pair of N's. And I'm taking out a pair of P's, but I'm left with 1 on the inside. So it looks like I'm going to have a 2P left over on the inside. And then I've got an M and N a P here, and then the -2 got multiplied to the 10, so that's going to be a B. All right. Over here, same process. We're looking at 288, and we want to find pairs. So I want to think of the highest perfect square that'll go into both of them, but unfortunately I can't. I don't have a chart in front of me, so I'm just going to go by 2. This I can do in my head. 2 is prime. That's 144. Okay, that's great. Perfect. Because that's a pair of 12s. I know that one. All right, so it looks like a pair of 12s is coming out. 2 is going to be left. Okay. Looks like I'm going to have 1H left over on the inside, but 1H coming out. I'm going to take out both J's, and I'm going to take out 1K, but I'm going to have a K left over. So looks like the 2HK is left on the inside, and I got a 12 times 6, which is 72, and then an HJK, and that has to be C. All right, so these guys kind of crept. These are just like the other ones. Yeah, I'm going to take the square root of both of them, and then I will raise it to the third power. So remember that this guy, and this is a really, really important skill because it happens so much the more advanced math you go. So you'll notice then that that 2 in the denominator here just says take the square root, so that's going to give me a 9V, but then the 9V gets raised to the third power. So 9 to the third power is 81. It's going to be 729V to the third. Okay, so just remember that you take the root and then raise it to that power right here. 5th root and then raise it to the 4th power. So let's see how many 5 times what looks like this is 10 to the 5th power. So I'm taking out I'm taking a 5th root out of that whole thing first. And I'm taking a 10, and I'm taking, there's going to be 5, it'll go in there. I'm taking 3 groups of N's. Okay, that's getting raised to the 4th power. So now I'm going to have 10 to the 4th power, which is right here, 4 zeros, and then N getting raised to the 12th power, and that's here. So that's A. We've got a whole bunch of 2's. Let's just follow the rules of exponents here. Whenever I have parentheses and I see that they're raised to a particular power, that is going to be multiplication. But when I have the bases separated like this and I'm multiplying, okay, this means that I add the exponent. So that's 2 to the 9th. Now, since I have 4 2's in the denominator, that means that this is a top heavy of 2's. And so all of those 4 of those 9 factors would get slashed away, and you're going to be left with 5 in the numerator. So it would look like this, okay? And so the answer for that one is D. Remember, negative exponents means that they're in the wrong location. So we're going to have to do some juggling here. We're going to move. 2's not going anywhere. He's going to stay. All right, so we actually already know our answer, which is cool, but let's just see how this works. Those x's will go down. Those y's will go down. This guy ends up being a y to the -3rd, so that y will go up because he's in the wrong location. He's in the denominator. So if he's got a negative exponent, he will go up. Now there's still an x down there, and so when you kind of put all this together, you end up with a top-heavy set of y's, which just one y there, because those cancel out and get absorbed by those 3. And then those 3 x's just add up together there. So our final answer is B. All right, so we've got some square root equations. The first two are going to be pretty simple. Remember, you always want to, well, you want to remember to check for extraneous solutions. We'll do that. But also, you want to isolate the radical so that you can square it on one side. I cannot square this until that 5 moves over to the other side. So once he moves over, he'll become positive. Okay. So now, what I want to do is undo the radical, and I do that by squaring. If I square both sides, I undo the radical. Okay, it's an inverse operation. So now I'm back to a two-step equation. I move the 2 over to there for a positive 24 over on the left, and that's a negative 4r. Divide both sides by negative 24, and I get an r equals negative 1, but I only get one of them. And it looks like, let's just double check, I don't see any extraneous solutions, and only one answer popped out. So this means then it's got to be A. Here for this guy, this is cool. They both have a radical isolated on both sides. So what this means is if I square both sides, I effectively just have undone the entire process, okay? Now don't be worried about a fraction in the radical. It's actually quite simple. If I want to get this guy to not have a fraction, just multiply it all by 4. So if I multiply this side by 4 and multiply this side by 4, I end up with this even easier problem. 4 times 35 is going to be 2. That's 140 minus x equal, whoa, is that right? 35? Just let me double check here. I don't trust myself. Yeah, that's right. And that equals x. Why does that not feel right? Not vibing that one. Right? Is that right? Square both sides. Da 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 da. Both sides by 4. 20. 2x. Divide both sides by 2. Getting x equals 70. Did I edit? Dumb mistake. When I did not distribute the 4 to that guy. So when he moves over here, it'll become a 5x. Okay, so there we go. Now I'm going to go 140 divided by 5, which is going to make a lot more sense. 5 goes in there twice, and then 8, so that's 28, and I only get one answer, so 28 is not going to give me the square root of a negative number. 35 minus 28 is actually square root of 7. This also would be the square root of 7. Square root of 7 equals the square root of 7. That is correct. That's not a problem. All right, this guy here. Okay, now we're really going to be careful and check for extraneous solutions, because when I square, this radical is isolated, so when I square both sides, it produces an a squared over here. Okay, now this happens all the time in more advanced mathematics, so you want to get real comfortable undoing radicals. When you do that, he gets squared, and now you've got a full-blown quadratic, and there's a reason why we spent so much time solving them, is because we need to set them equal to 0. And now we use the x method, factors of 49 that add up to negative 14. That is a negative 7 and a negative 7. So this means that a minus 7 times a minus 7 equals 0. The only number that will produce a 0 there is a positive 7. So a equals 7. There's only one number that came out. When I plug it in here, I get a positive 7. Negative 49 plus 14 times a positive 7, that's 98. Yeah, okay, so that is correct. So it looks like B is the answer. Here, same process. V gets squared, and then it equals 42 minus V. That's a quadratic. Move everything over to the left because you need this guy to be a positive 1. Keep him there. I know you could move him over here, but then the V squared becomes negative. You don't want to do that. You want to keep this A value positive. Remember, an A value springs from this, right? Okay, we want to keep that A value positive, so then that way positive 1 is even better, because that means that you can always use the x method. So here we want factors of negative 42 that will produce a positive 1, and I'm getting a 7 and a negative 6. So this means that V plus 7 and V minus 6 equals 0. So I get a V equals negative 7 and positive 6. All right. Now negative 7, when I go back here, okay, that's a problem because the square root cannot equal, no matter what it is, if I took the square root, I cannot equal a negative number. So negative 7 is one of those extraneous solutions. So 6 is the only thing left because it will produce a positive number. 42 minus 6 is 36. Square root of 36 is 6. So the answer there is B.